This is a photograph of the Earth. You know, if you grow up in learning about the Earth in grade school and high school, you have all the nations are on it and everything. But when you actually see an image of the Earth, it's none of those lines are on it. It's, however, there is one feature, one of the more dominant features of the Earth called the equator. You remember the equator? You can see it, can't you? Can you see the equator? Let me draw it for you. See it? See that band of clouds? That's the equator. And so there are processes taking place at the equator that do paint it across the Earth's surface with clouds. The hottest part of the Earth is along the equator because that's the part of the Earth that faces closest to the sun. It bulges out. It's like, you know, if you have a beer belly and you're standing, if you have a beer belly and you're standing in front of the campfire, your belly's going to get warm before your head gets warm because you got this big beer belly because it's closer to the fire. And so here's the Earth's beer belly here. So the part sticking closest to the sun is going to get more radiant heat from the sun. It's going to heat up. The equator is the hottest part on the Earth's surface on average, the highest average air temperature. And so it's in that area where the air at the level of the Earth is heating up most rapidly, and as that air heats up, it rises. It expands, becomes less dense, rises up through the cooler air, and as the warm, moist air reaches the higher altitudes, it becomes colder. And since it's colder, it can't hold the moisture, and so the moisture comes out as little droplets. And those little droplets that are being suspended by the upward movement of air are what we call clouds. And there are the clouds. It's like when you have a nice glass of sweet tea with a lot of ice, and it gets wet on the outside. And you think, why is it wet on the outside? It's because the ice inside of your iced tea is causing the glass to become cold, and that cold glass is cooling the air, a rine of air right around the outer edge of the glass, and that air is fairly high in humidity, especially in the south if you're out on the porch or whatever. And so the water that's saturated in that air comes out of solution because it's now cold because of the ice, and it clings to the outside of your glass. So that water didn't come from inside. The water came from the air outside. And when that happens in the upper atmosphere, those little droplets don't stick to glass. They stick around little dust grains, and they float in the air by this movement of upward air, and that's clouds. Yeah, Katie.
Okay, so I took a trip to Chicago when I was like 15 or 16, and one of the things we realized when we were like drinking like tea or water or whatever we were drinking, that our glasses didn't sweat.
Really?
Yeah, and it was really odd to us. We thought it was spring break, so it was springtime in March, and it wasn't sweating at all. Like,
because the air was probably pretty cool, right? So the air is cool, so you don't have the temperature difference. And it probably, if you're up in Illinois along the Great Lakes, it may not be as humid, especially in the springtime. As closer you get to the Gulf of Mexico, the more humid it gets. I grew up in Baytown near Houston.
Oh, man.
96 degrees, 70, 80% humidity. It's like when you walk out, you can feel the moisture. You're breathing it. You can feel it in your lungs, and it's like presses on you. And I just grew up that way, so I thought this is the way it is everywhere. And then when I moved to Austin, it was so amazing, because even in Austin, which has a high humidity, it was nothing compared to Houston. And occasionally I go visit my family and in the summertime, and it just weights you down. Okay, and that's the humidity in the air, the moisture. Okay, so as the air is rising, it suspends these droplets of water, which forms the clouds, and eventually those droplets will grow to a size that they begin to block out the light coming from the sun, and the white clouds become dark clouds, and eventually the droplets will become so large that they're heavy enough that the updraft, the upward moving air, can't keep them aloft. And so then they fall back to the earth. And when they fall back to the earth, that's rain, essentially. Okay? One time I had a ping pong ball in my closet, and I would show you. I could take the ping pong ball and keep it suspended. And I had a bowling ball, and I'd try to suspend that, and it never worked. Oh, we got a ping pong ball. I should have known Sergio would have it. I only need one. You don't have a bowling ball, do you?
Oh my gosh, how much we set aside?
So this is a water droplet. I'm going to make a cloud. I'm not very good. Out of practice. A little precipitation on it too. All right. But you get the point. You could keep it suspended. If I was a larger updraft, I could keep it going. So when the rain falls back to the earth, it waters. It's like a big irrigation system along the equator. See that dark zone there? In Africa, that's the Congo region. It's a rainforest.